So let's talk just a minute about measures of position. This will be pretty easy. Have you heard of quartiles before?
Yes.
Yeah.
Tell me what you know about quartiles.
That's how it ranks. Yeah, that's how it ranks.
Exactly. Because if you're in the top 25% of your class, do you get certain perks?
Not really.
Well, top 10% for sure. But if you look,
You don't have to
well, hang on.
really high test scores to get
Exactly. If you look at admission standards at different colleges, a lot of times, as long as you graduate in the top 25% of your class, you've got a lower requirement, say on an SAT score, in order to be admitted than if you graduated in a lower quartile of the class. And because it's a quartile, how many parts do you think that means it's been divided into? 4. Very good. Now, if we just call it a fractile, that means it sounds a little bit like fraction, doesn't it? You've just divided it into some kind of equal parts. If it's quartiles, we know it's 4. And these are very typical as far as ways to divide up, and they're also useful if you understand the way that it works. So what it means if you're in the first quartile is about 1/4 or 1/4 of your data would be below wherever Q1 is, wherever that dividing line is for the first quartile. Your second quartile means you've got half that would be on or below. Well, if I'm exactly in the middle, what does that mean? That value is also called the median. That's the value that's in the middle. Third quartile means 3/4 is below, and if I'm out at the 4th quartile, I got it all. Okay? Now, here would be the number of nuclear power plants in the top 15 nuclear power producing countries in the world. And this is old data. They haven't told us which countries these came from, but do you see one number that looks pretty different from the others? That 104 kind of jumps out. If you were guessing, who would you figure has 104 nuclear power plants? I don't know. I would think it might be the U.S. Maybe not. Okay. Now, guys, listen. I want you to tell me, hold it, if I want you to find the first, second, and third quartiles of the data set, how will you go about doing that?
Put them in numerical.
Okay. She just said you got to put them in order. She said numerical order, so I think what she means is from least to greatest, right? Just like if we were looking for the median, we'd have to order the set. Let's order this set. Okay, you ready? You need to write this down. All right. So when we're looking at this lower set, we're going to have to get the middle number in the lower group. 1, 2, 3, 4, 5, 6, 7, 10 was right in the middle. Okay? And that means if I do the same thing on the upper half, 31 is the median of the upper half. That's my Q3. Now, if we interpret that, it means about 1/4 of the countries would have 10 or fewer nuclear power plants. Half have 18 or fewer, and about 3/4 have 31 or fewer. Okay, so that's just giving us a way to organize this data. The interquartile range means if I find the difference between my Q3 and my Q1, that gives me the middle portion of my data. Okay, wouldn't that probably be useful information? Because that's going to be where the ones in the middle are clustered. The ones on the ends are obviously more different from the rest of the group than the ones that would be in the middle. So if I take Q3 minus Q1 for this information that we have here, I'm going to get what value? Q3 is 31, Q1 is 10. If I take the difference, I get 21. So it means that middle group only has a spread, a difference of about 21 between what the lowest country has in terms of the number of power plants compared to the one that would be my Q3. Now, here's where this is kind of helpful visually. Have you guys ever made box and whisker plots before?
Possibly, I don't know.
Okay, it's called box and whisker for a very logical reason. When you look at what it looks like, it gives us the ability to make a little visual graph that represents what we see here. So you're going to need your lowest number, your largest number, your Q1, your median, and your Q3. That's your 5-number summary. Okay, you're going to need all that information to draw a box and whisker plot. So let me just show you real quickly using the data we have on the board. Okay, so to draw your box and whisker plot, you got to have the 5-number summary. You need a horizontal scale, not the way I did it, but really actually mark off legitimate units so that you can see the range of the data, and then you plot the 5 numbers above the horizontal scale. So this would explain your Q1 and your Q3 will be the ending points of your box. Your whiskers will go out to your minimum and out to your maximum. And then you want to show where the median belongs by drawing that inside the box. Okay? So look at what this looks like with an appropriate scale. Would you say that thing has one long whisker out to the right? It does. In fact, even before we saw it this way, would you say that looks very different from the rest of the numbers?
Oh, yes.
Okay. There is a name for that when it is very different from the rest of the data. It's kind of like when we talked about if Grandma Jenny was in here and we tried to calculate the mean. Do you remember what word describes it's an outlier? Because it is so different. Now, when you have an outlier, okay, you want to have the ability to indicate that. So actually, let me go back and I want to show you something real quick. Hold on. All right, so quartiles. Definitely we use those the most. Divides it into how many parts? 4 equal parts. Deciles would divide it into 10 because DEC is the prefix that means 10. And percentiles would be 100. So like when you get your percentile scores back on something like your SAT, it's out of 100%. What percent did you score better than? Okay. Now, if we wanted to interpret percentiles, remember how we mentioned an ogive earlier? That's where it's all cumulative. You just keep adding on. And this is an ogive for the cumulative frequency distribution for SAT scores of college-bound students in a recent year, okay? What test score represents the 62nd percentile? If you got your test score back and it said you were in the 62nd percentile, if this was the correct graph, that would mean you scored about what? Well, here's 62 about. If I track over, that's about what score? Looks like maybe about 1600, right? This was on a 2400 scale. Okay, so a score of about 1600. 62% of students had an SAT score of 1600 or less. All right, last thing to cover, and then we're done with chapter 2. Standard score or Z-score. We will come back and do a lot with this later in the semester, but you need to kind of wrap your brain around the idea here. That would represent the number of standard deviations that some given value would fall from the mean. Now, what it does is it gives us a tool where we can make comparisons between things. You ever heard somebody use the expression, well, that's not an apples to apples comparison? You never heard that expression? Goodness, Daniel, there's so many things you haven't heard. We're going to have to get you up to speed. Okay, hang on. So, there, I mean, how do you compare, let's say you worked in a zoo, and so you were trying to determine if you had a bigger weight loss going on in, you know, Bimbo the elephant compared to, you know, Cookie the monkey. Okay, so you've got a monkey and an elephant, and you want to know which one has lost more weight, because you can tell they're both losing weight, but which one is losing more weight? How do you figure that out? Okay, you are going to have, hey, shh. If I just leave it in pounds, obviously the elephant is going to have lost more pounds than the monkey. But I need to figure out some way to make a comparison. So Z-scores let me do that. It standardizes things by taking the mean and the standard deviation for whatever you're working with and gives me the ability to make those comparisons, okay? So whatever the weight would be of the monkey, if I were to subtract the average weight of monkeys and divide it by the standard deviation, that's going to give me some Z-score. So I can tell if it's above the average or below the average. I could do the same with the elephant, and then I would be able to tell which one is more out of the ordinary. So here's the last thing we're going to do. 2009, Heath Ledger won the Oscar for Best Supporting Actor. He was 29 years old. Penelope Cruz won the Oscar for Best Supporting Actress. She was 34 years old. The mean age of all Best Supporting Actor winners is 49.5. And the standard deviation is 13.8. The mean age of all Best Supporting Actress winners is 39.9, and the standard deviation is 14.0. Now we need to find Z-scores that would correspond to the ages of Ledger and Cruz so we can compare and see which one is more out of the ordinary. Now, obviously, are they both younger than what the average age is? Yes, but remember, there's more to look at than just the mean. We also have to pay attention to standard deviation. And would you say the standard deviation for the Best Supporting Actress is actually bigger than the standard deviation for Best Supporting Actor? By a little bit. So we've got to come up with a way to compare these apples to apples. Now, using the formula, we're going to set up for Heath Ledger and Penelope Cruz a way to find the Z-score. Now, the formula is this. Z equals, guys, y'all are way too chatty. X minus the mean divided by the standard deviation. So what was Heath Ledger's age when he won? 29. Minus, what was the average age? 49.5. Okay. Divided by, what was the standard deviation? 13.8 for Best Supporting Actors. Okay, I need somebody with a calculator to run this computation. In a minute, you're going to tell us what you get. For Penelope Cruz, same formula, but what was her age when she won? 34 minus, what was the average age for actresses? 39.9, and their standard deviation was 14.0. Okay, and so somebody else crunched the numbers on that. Now, for Heath Ledger, all right, Daniel says he got negative 1.5. Anybody else get that? 29 minus 49.5 divided by 13.8. You said it's negative 1.5?
Sorry, it's negative 1.48.
Yeah, let's keep a few more digits. So negative 1.48 is fine. All right, what about this one? For Penelope Cruz, 34 minus 39.9, and then divide that by 14, you got
Negative 0.421.
so 0.42, and it's negative. Now, talk to me for a minute about what these numbers tell us. Remember, we are trying to come up with a way to compare these, and it said the Z-score would tell us how many standard deviations above the mean or below the mean. That's what the Z-score represents. So what do you think the fact that my Z-score is negative means? It's below the mean. And doesn't that make sense? Because they were both younger than the average age when they won. All right? If they'd been older, it would have been a positive number. So he would be almost 1.5 standard deviations below the average age. she would only be 0.42 standard deviations below. So which one would you say was more out of the ordinary, or Heath Ledger? He was further from the mean than Penelope Cruz was. Now, here's what I want you to see as far as what that tells us. If somebody got below -2 or above +2, that's more than 2 standard deviations. You know how we talked about unusual values, those outliers? They occur if you're more than 2 standard deviations. So, because neither one was smaller than -2 or greater than +2, we wouldn't call them unusual or like they were outliers compared with others. But he was relatively younger compared to Cruz, who was closer to average. Make sense? Okay, so let me stop this.